Hey guys, Fred here, AF Math and Engineering. How's it going? We are going to solve a couple more problems in the topic of implicit differentiation. We're going to do a couple trickier problems, I guess, and we are just going to go through them step by step and really just help you understand what the tricks are and prepare you for the midterm that you're going to take soon. So with that being said, let's go ahead, let's get started. And let's take a look at the first question. So we have implicitly differentiate tan inverse of x squared y equals x plus xy squared. All right, so this is the same thing as arctan or inverse tan. Okay, don't get it confused with 1 over tan because those are different things. That's cotangent. But what I've done down here in the pink is I've written the rule for the derivative of an inverse function of tan inverse. So we have d by dx of tan inverse x is equal to 1 over 1 plus x squared. So that is the rule for this particular inverse function of the derivative. Go to your textbook, search online. There should be the rest of the derivatives for the inverse functions. I'm not going to write them all down here, but you should have them in your textbook. So just make sure that you know at least sine, cosine, and tangent for the inverses, the derivatives of those, because those always come up. With that being said, let's get started on this question. So, as we've been talking about with implicit differentiation, we use it when we have a function that relates two different variables to each other. So in this case we have x and y in the same equation. So we know that we're going to have to implicitly differentiate. If it didn't tell us to, then we would know that. So let's go ahead and get started. And right off the bat, let's start with the left side of the equation. So we have the tan inverse here, and let's go ahead and apply the derivative to it. So we have 1 over 1 plus, and instead of x we have x squared y here, so we're going to do x squared y, and that's going to be squared. All right, and if you remember with the chain rule is that we take the derivative of the outer function, all right, and then multiply it by the derivative of the inner function. Okay, so in this case the inner function here is x squared y, all right, that's our g of x. So we're going to need to multiply this function by the derivative of the inside of this bracket here, which is x squared y. And in order to do that, we're going to have to use the product rule. So this is kind of like, this question is a combination of 3 different techniques that we've learned. We're using implicit differentiation, we're using chain rule, and we're using the product rule. So let's go ahead and differentiate this using the product rule. So the derivative of x squared is 2x times y plus, and we're going to go ahead and implicitly differentiate y with respect to x. So that's going to give us, well, the derivative of y is just 1, and we're going to add our dy by dx. So, and we're just going to multiply by x squared. Perfect. All right. So, and that is going to be equal to, and let's just do the right side of the equation here. So we have x plus xy squared. So derivative of x is 1. xy squared, well, we need to use the product rule again. Derivative of x is 1 times y squared plus the derivative of y squared is 2y dy by dx. Always remembering when we're implicitly differentiating y with respect to x, we're going to add our dy by dx, and then we're just going to multiply that by x, all right? So that's done. Let's move on to the next step below. And the next step involves, if you'll remember from the last video, taking the dy by dx's and moving them to the same side of the equation. So the first step in accomplishing that is going to be to expand this bracket so we can isolate this dy by dx. So let's go ahead and do that. So we're just going to multiply this bracket into this fraction. All right, x squared over 1 plus x squared y squared dy by dx equals 1 plus y squared plus 2xy dy by dx. Perfect. So let's go ahead and move all the dy by dx's to the left side. And taking this, moving it to the other side. And we are just going to leave the 1 plus y squared, and we're going to move this term to the other side. All right, perfect. So this is looking like we can isolate for dy by dx, which is what we want to do when we're asked to implicitly differentiate. And we can do that just by factoring this out here. So let's go ahead and do that. Okay, That's looking pretty good. So now we've accomplished what we wanted to do. We've isolated dy by dx, and all we have to do is divide both sides by this term here. And I'm just going to come down here. We have a little more space. So dy by dx is equal to 1 plus y squared, and I'm going to just distribute this square now. And that is divided by this term here. And there we have it. We've solved the question here. We've solved for dy by dx. This is definitely, potentially, this could be cleaned up a little bit more. We can go ahead and simplify that. I suggest you try that on your own. So up to this point, and this is a 2xy. Sorry, my writing is not looking good there, but that does say negative 2xy. I would suggest that you go ahead and repeat this problem, because this is something that you could definitely see on an exam. It's definitely tricky enough for a professor to put that on an exam. Go through all the steps and then try and clean this up. Clean it up and see if you get the same thing. So let's take a look at the second one. The question asks us to implicitly differentiate 4 cosine x sine y equals 1. Once again, we have two different variables related to each other, and we're going to have to differentiate implicitly. And because we have the product of two functions multiplied by each other, we're going to use the product rule. So with that being said, let's get started on that. So as we know, the right side of the equation is going to be 0. Derivative of a constant is 0 with respect to whatever, it doesn't matter, x or y. And we have, so let's just start with the left side. So let's take this 4 and we'll move it outside, okay? Because the 4 doesn't really come into play. So let's take the 4, we'll move it outside. All right, and then we'll take the derivative of cosine x with respect to x and multiply it by sine y. So the derivative of cosine x is negative sine, as we discussed before, times sine y. All right, and we're going to add that, so then we have plus the derivative of sine y, okay, with respect to x. So that's going to give us cos x times cos y dy by dx. Perfect. And, all right, that is going to be equal to the derivative of 1, which is 0. All right, so that's looking pretty good. How can we now isolate for dy by dx? And as we discussed many times before, we want to put dy by dx by itself on one side of the equation. So this 4 is going to disappear, obviously. And we are going to be left with moving these signs to the other side of the equation. Perfect. So let's go ahead and isolate for dy by dx quickly. All right, and if you can see here, we can do a quick simplification if we know that sine over cos is equal to tan, right? So we have sine x over cos x, and we have sine y over cos y, which ends up being the product of two different tangent functions. So we have tangent x, tangent y. There's a little kind of simplification trick there. And there we have it. We've solved 2 questions, all right? Hopefully this makes sense. This is probably one of the easier subjects in Calculus 1. There aren't too many tricks, but for example, in the first question, we had to use a combination of 3 different things that we learned in the course. So we had to use the derivatives of inverse functions. Then we had to use the chain rule, because we had this function inside of the function. And then we had to implicitly differentiate, because we had a product of 2 different functions. And then we had to use the chain rule. So that's about as tricky as it gets, and that's where the tricks come from in this topic. So thanks for watching. We're almost finished Calculus 1. We got a few more topics to cover, so come back for those. Hope you're enjoying the videos. Like and subscribe if you are, and thanks again.